Welcome to Study Loop.
First, we will calculate the final temperature after mixing 3 kg ice with 6 kg of water. Let T prime is temperature at equilibrium. So by using law of heat exchange, we can write heat released by 6 kg hot water is equal to heat absorbed by 3 kg ice. Heat released by water, that is equal to m times c times delta t. M times c times delta t. Here m is mass of water, which is 6 kg, into specific heat capacity of water is 4186 joule per kilogram per degree centigrade, and change in temperature is here 85, that is the initial temperature of water, minus the temperature at mixing is T prime. So this is change in temperature of water. Here we are only dealing with the magnitude of change in temperature. So that is equal to heat absorbed by 3 kilogram ice. So first 0 centigrade ice will convert into 0 centigrade water. So heat absorbed by 0 centigrade ice to change into 0 centigrade water is m times latent heat of fusion. So here mass of water is 3 kg into latent heat of fusion of water is 33.5 times 10 to the power 4 joule per kilogram, plus heat absorbed by 0 centigrade water to change from 0 degree to T prime is mc delta t. Here m is 3 kg into value of c is 4186 joule per kg per degree centigrade, into change in temperature. Here is final temperature is T prime, and initial temperature of water is 0 degree Celsius. So this gives us, so 6 times 4186 is 25116 joule per degree Celsius, into 85 degrees Celsius minus T prime equal to 3 times 33.5 times 10 to the power 4 is equal to 1.005 times 10 to the power 6 joule, plus 3 times 4186 equal to 1255 at joule per degree Celsius, into T minus 0 is T. Now this gives us 25,116 times 85 joule minus 25,116 into T prime joule per degree Celsius equal to 1.005 times 10 to the power 6 joule, plus 1255 at T prime joule per degree Celsius. So T prime, here we have two terms having the having T prime. So we will add these two terms. So this gives us minus 25116 minus 12558 T prime joule per degree Celsius equal to 1.005 times 10 to the power 6 joule minus 25116 times 85 joule. So this gives us T prime approximately equal to 30 degree Celsius. So this is the final temperature when ice is mixed with water. Now we can easily calculate change in temperature of ice and change in temperature of water. So first we will calculate change in change in entropy of ice when it melts at 0 degree Celsius. So by using the relation change in entropy of ice equal to Q upon T, here heat is absorbed by water. So here heat is absorbed by ice to melt. So we will take it positive, and here Q is m into latent heat of fusion of water upon temperature is 273 Kelvin. M is 3 kg into latent heat of fusion for water is 33.5 times 10 to the power 4 joule per kg upon 273 Kelvin. This gives us change in entropy of ice equal to 3681.32 joule per Kelvin. Now in the second part, we will calculate change in entropy of 6 kilogram water when it cools. So change in entropy of 6 kilogram water when it cools from 85 degrees Celsius to final temperature, that is 30 degree Celsius. And we already have the relation for change in entropy which is given in the problem, that is delta S equal to mc into log of final temperature upon initial temperature. Now by plugging different values here mass of water is 6 kilogram, specific heat capacity of water is 4186 joule per kilogram per degree centigrade into log of final temperature is here 30 Celsius, which is 30 plus 273 Kelvin upon initial temperature of water is 85 degrees Celsius, which is 85 plus 273, that is in Kelvin. So this gives us change in entropy of 6 kg water when it cools equal to minus 4189.35 joule per Kelvin. So here Entropy change is negative. This shows that entropy decreases when water cools. Now in the last, we will calculate change in entropy of water when it warms from 0 degree Celsius to 30 degree Celsius. Again, by using the relation delta S equal to mc log of final temperature upon initial temperature. Here mass of water in this case is 3 kilogram. Specific heat capacity of water is 4186 joule per kilogram per degree Celsius into log of final temperature here is 30, that is 30 plus 273 Kelvin, and initial temperature here is 0 degree Celsius, which is equal to 0 degree plus 0 plus 0 plus 273 Kelvin. So this gives us change in entropy equal to 1309.31. So here change in entropy is positive. This shows that entropy of water increases when it heated from when it warms from 0 degrees Celsius to 30 degree Celsius. Now we want to calculate net change in entropy. So net change in entropy, that is equal to entropy change of ice plus entropy change of 6 kg water when it cools, and entropy change of 3 kg water when it warms. Now by plugging different values here, delta S ice is 3681.32 joule per Kelvin. Delta S1 is minus 4189.35 joule per Kelvin, and delta S2 is 1309.31 joule per Kelvin. So this gives us net entropy change equal to plus 8.0128 times 10 to the power 2 joule per Kelvin. So this is the entropy of entropy change of universe. So here positive sign shows that delta S is positive. So positive sign shows that entropy of universe increases. That's the end of the problem. Thanks for watching.